So here we have tutorial of the application of Laplace transform to circuits. So basically, from the previous videos, I have taught what a Laplace transform is. So these equations, we have to be familiar with it. For a resistor, the voltage drop across the resistor is just R, the resistance, multiplied by the current through Rs. And then for the capacitor, the voltage drop equation in the Laplace transform would be 1 over S multiplied by the capacitance times the current sub C plus Vc of 0 over S. So here, the V sub C of 0 over S represents the initial condition. Why do we have initial condition? For example, in a steady state circuit, such as those circuit which has switches or time is less than 0, for a capacitor, when the switch is off, basically there is a current or voltage, there is current. So why we have a positive initial condition here is that this accumulated energy before time equals 0 is added to the voltage drop of the capacitor. So it just adds. While for a conductor, the voltage drop across a conductor is S multiplied by L, or the inductance, times the current sub L minus L times L sub I sub L of 0. So here we have a negative sign because a voltage drop across an inductor is subtracted by the voltage that resists the current even before the switch happens or the switch is on. Basically, an inductor acts like a resistor that, in a way that it opposes the flow of current. Thus, there is repulsion here, so we have to minus it with the total with the voltage drop. So basically, these are the conditions for the steady state. So here we have the capacitor in the time domain and the inductor also in the time domain. So if we have to transform this into the S domain from the time domain, we just have to redraw it as this. As you can see here, the positive sign is beside the capacitor because we add accumulated energy in the capacitor since it stores energy at time is less than 0. So here we have 1 over C, and for this one we have minus plus. Here we have minus beside the inductor because it subtracts from the voltage drop of this. So we just have to write here S multiplied by the inductance. So next is that we have a very basic problem of circuit problem through using Laplace transform. But before we go through that, I will present to you some steps to remember so that we could perform. So that we could perform the operation or the circuit problem. So here are the steps to be remembered. One is to transform the circuit. So obviously, since from the topic itself we are using Laplace transform, we have to transform the circuit that is from the time domain to the time domain, we write it here, to the S domain. Sorry for that. Domain. Oh my god, it's another paper, sorry. So basically, it's just time domain to the S domain. And then 2, we have to solve the circuit using any circuit analysis technique. It could be nodal analysis, mesh analysis, superposition, voltage divider, or even Ohm's law would do. Anything that you seem to be fit through solving that problem, whichever you like. So here, we just underline it, circuit analysis. And lastly, when we get the solution here from solving the circuit, we have to take the inverse Laplace. So this is read as the inverse Laplace. Why do we have to take it back into the time domain? Basically, we start from the time domain and we just transformed it into the S domain so that we could simplify, so that we could compute for a problem using the Laplace transform, which just basically makes it easier for us. We just have to put it back from the S domain or back to the time domain. So I forgot to say that the S domain is the frequency domain. Basically, the Laplace transform uses a frequency domain, and while the Z transform from the previous lesson is that it is in Z domain. Okay, so I think now we are ready for solving a problem. Okay, here have your problem. So given we have this circuit, the voltage source is U of t, no constant given, just U of t, and there we have a 1 ohm resistor, 1/3 farad here. In parallel with a 5 resistor ohm and a 1 Henry inductor. So our goal here is to find the VO sub t, which is basically the VL, or the voltage drop across the inductor. So first, from the steps, remember that we have to transform the circuit elements into the Laplace. Or the frequency domain. S is the frequency domain. So U of t, the Laplace of U of t, basically this is just 1, and its Laplace is 1/s. And for the inductor, 1 Henry SL, we just have to plug 1 here through the L. Basically it becomes S, and 1/3 farad here would be 1/s. C is equals to, just plug in 1/3 here in C, and we get 3/s. The resistors basically remain the same. We don't have to transform it to a Laplace. Only the capacitor and the inductor. So now that we have transformed it, next step is to solve the circuit using any circuit analysis technique. So basically here, I think we have to use a mesh analysis so that we get the current 1 here and current 2 here. So we're drawing the circuit with the transformed circuit elements. We have here 1/s, the voltage source from the U of t, and 1 resistor ohm, which remains the same, the 3/s capacitor, in parallel with 5 ohm resistance, and the inductance that becomes S. So we have, our goal is to find the value of I2 so that we could get the voltage drop across the inductor. So in order to find the current of sub 2, I sub 2, we have to know what I sub of 1 is first. So since we are using mesh analysis for this, just have to write it down, mesh analysis. Actually, you could use anything, any circuit methods you would like, whichever you like, but I think that mesh analysis would be appropriate here, because since I think it would be easy. So for mesh 1, we have here 1/s, is equal to the voltage drop of the resistance here and capacitor. It becomes 1 times current 1, we just have to call current 1, I guess, and plus 3 over S multiplied by 1 sub of I sub of 1 minus I sub of 2. And then regrouping here 1 and 3 over S, we have this equation for equation 1. So 1 over S is equal to quantity of 1 plus 3 over S multiplied by the I1, I sub of 1, and 3 of S multiplied by I sub of 2. So this would be our equation 1. So for mesh 2, we have here, since no source, it will be 0, and then negative 3S multiplied by I sub of 1 plus S plus 5 plus 3 over S multiplied by I sub of 2. So 5 ds and the 3 over S. So also by simplifying it so that we get I1 to be substituted in the first equation, we have 1 over 3 multiplied by S squared plus 5S plus 3 multiplied again by I sub of 2. So this is equation 2. So now it's easy, right? So now we have the equation 1 and equation 2. Next is to substitute this equation into this equation. We just have to plug I1 here. This is I1. I1. We just have to plug it there. So substituting, I'm sorry for that. My tongue is twisted now. So equation 2 to equation 1, we have here 1 over S is equivalent to 1 plus 3 over S multiplied by 1 over 3 times S squared plus 5S plus 3. So basically this is the I sub of 1. We just plugged it here. So by multiplying it by 3, it gives us, actually I just simplified it here so that our video will not prolong. It would be 3 is equivalent to S cubed plus 8S squared plus 18S times I sub of 2. And equating this equation, dividing this by S cubed plus 8S squared plus 18S so that we could isolate I2, we have here I of 2 is equivalent to 3 over S cubed plus 8S squared plus 18S. So now that we have the I sub of 2, we can now find the value of the voltage across the inductor. So basically V sub of 2, which is, this is just a VL, equals the inductance that we got is S, or the impedance of inductor, multiplied by I2. So we just plug it here, and basically we just simplified it so that S cubed becomes S squared and 8 squared here becomes S, because we just multiplied it here. Divided it by S. So, and then by furthermore simplification, it becomes 3 over square root of 2 times square root of 2 over S plus 4 quantity squared plus square root of 2 squared. So this equation seems a little bit familiar for us. So there is a direct substitution, there is a direct equation or formula of this in the table of Laplace transform. Recall that we have, for this type, we have E8t multiplied by sine A t would be, pt would be equivalent to the I mean this one. So we put s minus a over s minus a squared plus b squared. Oh, I'm sorry for that. Since we are using the sign, we have to use a here. We redraw that. So we have here EAT sine AT. And its equivalent in the Laplace transform would be s minus a over s minus a squared plus b squared. So here we have the b as, oh, sorry. I mean, sorry for that. I mean, basically it's right. The first equation, I got confused. So we have here, should be b. So b, you have here b. So we just have to know what b and a is. So for a, we have -4. A would be -4, and b is square root of 2. So plugging in the values here would give us a voltage drop equation would be 3 over square root of 2 multiplied by a raised to -4t sine square root of 2t volts. So basically, this is the final answer, my friend. Actually, it's not. Oh, we could further simplify it by taking the inverse Laplace of this. But I think the equation will be enough for now. So this is the answer at time is greater than or equal to 0. Thank you for watching.